All right, I'm gonna try to get the markup up here. Okay, I think we're good. All right, so I thought this would be easier to write. We already did this one, number 1. So if the first element is a metal, which all of these are ionic compounds, which means a metal plus a non-metal. Other compounds called covalent is a non-metal bonded to a non-metal. So you'll see non-metals as the first element here, and then non-metals as second. In this one, it's a metal and a non-metal. It's never going to be a non-metal first and then a metal second. It will always be the metal first and non-metal second. So we already said that Na2S is sodium, name of the first metal, and then sulfur, you change the suffix to "ide." And then the second one here, sometimes the first ion, because these are ionic compounds, ion means an atom with a charge, might be more than one atom, which they call polyatomic, because poly means many. So NH4 is one ion, is bonded together. So when that's the case, whoops, let's see if I can switch back here to our polyatomic ion sheet. We have to find NH4, which is, I thought it was on this one. Right here. Here we go. So ammonium. Right there. See NH4 plus? That would be ammonium. So that's what you do when you have a polyatomic ion. Let me switch back here. Now let me go to markup again. Wish it was a quicker way. And then we'll say ammonium. I'll just write it here so I don't try to put it all in that space. Ammonium, and then chlorine is the second. And then you, instead of saying chlorine, you say chloride. Okay, the next one, we said copper, and then because this is a transition element, we need to put its charge in Roman numerals. So how do you figure out the charge? Well, when they become a formula, you have copper and you have fluorine. Fluorine is in group 17, so it has 7 valence electron, which has a negative charge. You can also look at that polyatomic ion sheet, and fluorine will have that negative charge. Because there's no subscript down here, we know that copper is a +1, because when they form a compound, you take the charge and you crisscross to know what subscript you have. So that 1 comes by the 1 here, and that 1 goes right there. Basically, you're saying copper has 1 electron to give away because it's a +1 charge. Fluorine wants 1 electron, so they're going to bond in a 1-to-1 ratio. So that's why it's a 1-to-1 ratio, because copper wants to give away 1 electron, fluorine wants to gain 1 electron, so they only need 1 of each other to do this. An example for another compound here, if you look at number 1, sodium sulfide, to figure out that you need 2 sodiums, sulfur is in group 16. It needs 2 electrons, so it's a 2- charge. Sodium is in group 1. It has 1 electron to give away, so it's a +1 charge. When you look at those 2 ions to figure out this formula here, how they will bond, you switch these numbers to become subscripts of the opposite element. So that 2 comes here by sodium, which is right here in the compound, and that 1 by sodium comes here by sulfur. So that's why the compound is Na2S. It will always form that ratio when sodium and sulfur bonds together. So we know that copper is a +1 because there's no subscript here by fluorine, so we put a Roman numeral 1. So you can go like this if you want to. Okay, for the number 4, you have copper again. And to know the charge, remember in this example with arrows right here, this 2 came from copper and this 1 came from fluorine. So that means this copper wanted to give away 2 electrons. That's what makes transition metals kind of funny, because they can sometimes give away 1 electron, sometimes 2, sometimes 3, whatever. Okay, so the next one here, I'll do one more, and I think you could do the rest. Here's Pb, which is lead. And then you got SO4. So S is a nonmetal, so that's how you know that starts the polyatomic ion. So SO4 is a polyatomic ion. To figure out, and lead is a transition metal, so it has to have parentheses, by the way. To figure out the name of SO4, you have to go to your polyatomic ion sheet and find SO4. SO4. SO4 right here, bottom left. Do you see that? Sulfate, SO4 2 minus. So we know SO4 is a 2 minus charge. We can look at lead since we have it here. Lead could either be over here on the right hand side, 2 plus, or it could be a 4 plus. So how do we know which one it is? This will give us an example of what we do when we can, you'll see. So lead, sulfur we know is a 2 minus. Lead can either be a 1 or 2. Well, there's no subscript down here. I know there's a 4, but 4 goes with the entire polyatomic ion, so there have to be parentheses in a subscript. So if sulfur wants to gain 2 electrons, it will only need one of a lead atom if that one atom of lead wants to give away 2 electrons. So we must have the lead ion that is 2 plus, because sulfate is 2 minus. So the only way it can bond in a 1-to-1 ratio with lead is if we have lead that's 2 plus charge. So basically, if you're forming compounds, if you can simplify the subscripts, let's say if you have lead, if you knew you had lead 2 plus and sulfate 2 minus, you switch those charges and you get Pb2 SO4 2. Now, if you can simplify these subscripts, then you simplify. So really, this is an incorrect formula right here. It's really going to be what you see here at number 5, PbSO4, because you can simplify them. Okay, so the other ones we already did. The only thing here is right here, number 8 is not an ionic compound. It's a covalent compound. So I don't know if you have any on the second half of this worksheet, but if you have a nonmetal bonded to a nonmetal, you're not going to use